welcome to this explainer. Right now, a massive paradigm shift is happening literally right beneath our feet. When most of us hear the phrase artificial intelligence, we immediately think of software, right? We picture chatbots, lines of code on a glowing screen, or maybe those generative images popping up on our feeds. But today, we're going to dive into the data and the research to understand that AI is actually the most massive physical infrastructure build-out of our entire lifetime. We are quite literally building a global brain.
And just consider who is actually making these predictions. We're talking about Geoffrey Hinton, widely known as the godfather of AI, speaking back in 2023. He originally thought systems getting smarter than people was, 30 to 50 years away. Now, he estimates it could happen in just 5 to 20 years. Honestly, it's perfectly understandable why the general public is radically underestimating the speed of these industries right now. I mean, if the actual pioneers who built this technology from the ground up were caught off guard by its acceleration, it makes complete sense that the rest of us are just playing catch up.
So to truly understand this wild acceleration, we need to realize that we are fundamentally rewiring the digital world. To grasp this, let's use a simple analogy. Think about artificial neural networks. They're basically an interconnected group of nodes that loosely model the actual neurons in a biological brain. They're trained to recognize patterns in data. So instead of just writing linear step-by-step code, engineers have created a digital structure that mimics, well, us. The network has an input, these hidden layers of processing nodes, and an output. Once a weight or a signal crosses a certain threshold, boom, the data fires off to the next layer. It is quite literally an artificial brain. Think of it this way. For decades, the internet we've all been using was basically built like a giant series of plumbing pipes. Its main job was just moving data from point A to point B, sending your emails, driving web traffic to search engines, or pulling your files from cloud storage. But tomorrow's AI infrastructure operates entirely differently. Instead of pipes, think of it as synapses. It's totally focused on processing thoughts and making automated decisions through AI data centers, specialized accelerators, and advanced edge computing. We are shifting from a system of transportation to a system of cognition. And because of that massive shift in how things work, we've officially entered an unprecedented big tech arms race. The commercial reality here is completely dominated by a few familiar giants: Alphabet, Amazon, Apple, Meta, and Microsoft. According to the research, these major players already own the vast majority of existing cloud infrastructure and computing power. And because they already have the massive data centers, they're able to entrench themselves even further into the marketplace. For newer companies, competing on this physical, infrastructural level is becoming incredibly, almost impossibly difficult. Get this. These 5 companies alone are projected to spend a combined $602 billion in capital expenditures in the year 2026 alone. That is a 32% increase from just the year prior. But here is the truly staggering part. An estimated 75% of that spending is going specifically toward AI infrastructure. This isn't just some routine software update. It is a full-blown industrial revolution that requires immense, expensive physical hardware. To really ground this abstract concept into physical reality, just consider the entire country of Japan. A 2024 report from the International Energy Agency looked at projections for data centers and AI power consumption. They found that global power demand for these specific uses could literally double by 2026. That additional power consumption, it equals the electricity usage of all of Japan. That is the massive physical footprint of the global brain we are currently building. But, it's not all happening in massive, power-hungry data centers out in the middle of nowhere. This also manifests right in our everyday environments, through the artificial intelligence of things, or AIoT. This is how edge computing works. First, sensors collect data right at the source. Second, an edge processor runs the AI model locally, right on the device itself. And third, the system produces sub-second automated decisions. Because hardware costs have fallen so dramatically, we're now seeing instant, real-world action without needing continuous human intervention. Now, all of this hardware and edge computing is really just setting the stage for the next major paradigm in AI development. We are moving way beyond chatbots, and we're entering the era of world models. This is what's accelerating the path toward artificial general intelligence, or AGI, meaning systems capable of completing nearly any cognitive task at least as well as a human can. Today's popular chatbots are built on what we call large language models. And look, they're incredibly impressive, but fundamentally they work by predicting text based on data patterns. It's kind of like a super advanced autocomplete.
But Meta's chief AI scientist, Jan LeCun, alongside other major industry leaders, is championing these things called world models. These architectures are designed to actually understand reality. They don't just predict the next word in a sentence, they learn how physical environments operate and how physics actually works, much like a human does just by observing the world around them.
And think about what happens when you combine an AI that truly understands physics with physical edge computing. You get the robotics revolution. Historically, humanoid robots were explicitly programmed for very narrow specific tasks, and they basically just failed the second they encountered a new situation. But now, modern humanoid robots are transitioning entirely to machine learning and reinforcement learning. They are becoming incredibly flexible, much easier to train, and remarkably versatile, all because they can now dynamically learn from and understand their environment on the fly. So, where does this all lead? Let's take a look at some incredibly bold predictions for the year 2030. The top minds in the field are currently locked in these really dynamic debates over the timelines. Within just 5 years, Jan LeCun predicts a completely new paradigm of AI architectures, those world models we were just talking about. Sometime between 5 to 20 years from now, Geoffrey Hinton estimates we could actually see systems smarter than humans, and running parallel to all these mind-bending technological milestones is the unstoppable financial momentum. An estimated $2.7 trillion is projected to be invested in AI infrastructure in the US alone by the end of the decade. $2.7 trillion by 2030. To really put that into perspective, the consulting firm McKinsey notes that the sheer scale of this infrastructure spending will surpass the cost of World War II's Manhattan Project every single month. Let that sink in. We are literally watching the largest mobilization of technological resources in human history unfold in real time. Which brings us to the ultimate question we really have to ask ourselves as we build out this global brain. As the physical infrastructure scales up to these historic levels, as world models begin to truly understand physical reality, and as the timelines for artificial general intelligence keep shrinking, are we ready to share the world with machines capable of outsmarting us? The physical AI boom is already here. The infrastructure is literally being poured right now. The only question left is how society will adapt to the reality it creates. Thank you so much for joining me for this explainer.